perhaps China, no. So we need to work harder on the quality side. So we have to also work on that. So any ideas of what we can do, we'll be happy to hear. Finally, Triple IT Hyderabad, I think, is very close to Mr. Kohli's heart because his emphasis and interest in making sure computing reaches every Indian, regardless of linguistic diversity, was very strong. And in initial years, when Rajiv Sangal was there and now continuing also the Indian language program, so this is very special for him that this was also done in Triple IT Hyderabad. Thank you.
Thank you, Dr. Gautam Sharaf. So we'll move to the next speaker, Professor Madhav Krishna, who is head of KCIS, and he is going to provide an overview of KCIS now. Madhav, please take over.
Are you able to see my screen? Or?
Yes, we are able to see and also hear you.
Okay.
Not the screen. You are not seeing the screen.
Yeah, sorry.
Full screen.
Yeah. Yeah, so I'll proceed from here. This is a brief overview. KCIS started its operation in 2015 with a 60,000 square feet state-of-the-art research facility. The foundation stone for the Kohli Research Block, or KRB as we call it, was laid in 2015. The KRB itself was inaugurated with all the centers in 2017. It houses 7 centers, many faculty, postdocs, students, and is basically an umbrella center for broad areas in AI. So the KCS research is consistently showcased in premier forums in the respective areas of AI. For example, includes CVPR, ICCV, ECCV, and similar conferences in computer vision, AAAI, HKI, AMAS, UAI, in AI, ICML, and similar forums in ML, ICRA, IROS in robotics, DubDubDub, ECIR, interspeech and language technologies, and top forums like JOSA, COG, ISMAR, CHI, and COGSI. We are also rated pretty high in both computer science. In India, we are ranked 6th, Asia 36. Whereas if you look at AI plus robotics, we are ranked first in India, 25th in Asia, and things like that, to say that our presence is possibly being felt. The KCIS has an extensive outreach program that involves several workshops, summer and winter schools, invited talks of eminent AI researchers. A cornerstone of this effort is the executive education program for personnel and industry in the areas of AI/ML. Over 1,500 participants so far. Its success has spanned more programs, such as the one in data sciences, which we are just about to take off. So I'll come to the research centers under the umbrella of KCIS. CVIT is a household name amongst Indian and international vision community. Its research and tech transfer has made immense impact in wide-ranging areas that include top-notch research collaborations across eminent researchers worldwide, deep tech startups such as DreamU, executive education, summer and winter schools, and highly impactful social projects such as the Indian Brain Atlas. Its research spans OCR, deep learning, mainstream computer vision, robotic vision, medical imaging, computer graphics, amongst others. There are very well-known projects such as, for example, the CAD for Eye, which involves advanced prediction of diabetes, grounding in textual phrases, one that you see here, which has also been applied to autonomous driving. Computer vision meets sports, where we try to predict, we predict the sports seen out there, give commentary, analysis, even diagnosis, coaching based on sports video. And of course, omnidirectional stereo from a single camera, which has established itself as a very deep tech startup. The LTRC, or Language Technology Research Center, is also a popular name in Indian and international research community. Its central mandate, so as to speak, is about making language technologies work for the common user by developing Indian language speech-to-speech translation systems that include Telugu, Tamil, Kannada, Bengali, and other Indian languages. developing detection systems for hate speech, sexism, fake news, clickbait, amongst others, productizing conversational system for semantic search and question answering in documents towards deeper understanding of discourse both in English and Indian languages, speech processing, multilingual speech processing, pathological speech processing, and speech-to-speech translation. RRC, or the Robotics Research Center, is also well known in robotics research community. Its rainbow research spans a wide spectrum that involves mechanism design, novel socially impactful mechanisms such as pipe climber, reconfigurable drones at one end, to deep learning and autonomous driving at the other end. RRC has been funded over the years by several industries, DRDO, and government funding agencies. It has made technology transfers, some of them used widely, such as in autonomous driving. For example, this is a tech transfer involving foundational research in the area of nonlinear time scaling for collision avoidance amongst multiple robots, which forms the backbone of MathWorks' automatic scenario generation pipeline. Machine Learning Lab was started around 2017 and has quickly grown to showcase its impact in top-notch forums. It conducts research in both theoretical and algorithmic aspects of reinforcement learning, deep learning, multi-agent systems, game theory, mechanism design, blockchain, explainable AI, and fair AI. It has also started out a highly competitive PhD fellowship in the area of blockchain research. It would also be a prominent player in the TIH in areas relating to mobility and smart cities. KCCI, the Cognitive Science Research Center, is also famous, and its research and development focus spans perception and cognition, music, mind, and technology, brain cognition and computation, and perception engineering. It is deeply involved in highly impactful social research projects such as analysis of neural or behavioral correlates of rape victims for empathy, virtual reality-based systems for diagnosis, and therapy of amblyopia, human motor skills learning through reinforcement learning, brain marker analysis to determine rehabilitation success amongst drug users, and early warning strategies predicting the onset of depression. DSAC, or the Data Science and Analytics Center, conducts research, facilitates technology transfer, and builds systems in the broad areas of data engineering. One of the first centers to be started in IIIT, it has morphed and adroitly adapted itself to the changing needs of the time. Its research involves modeling, storage, and management, search, recommendation, and autonomous processing of structured and semi-structured data. Its research spans data analytics, visualization, database systems, electronic contracts, and workflow management, multi-agent systems, including multi-robotic systems. Within the umbrella of AI activities, there are a plethora of startups. It would not be possible for me to get into all of that, but maybe I will focus on DreamU, which is, of course, a startup founded by our moderator for today's panel discussion, Professor Anup, or Anup as we call him. DreamU is making waves with its unique technology that manages to get surround view depth from a single camera. Its elegant solution involves a combination of lenses that betrays the mathematical and engineering complexity that underlies the almost intractable problem in computer vision. It's an extremely challenging problem in computer vision to reconstruct a scene from a single camera, and all the more so if you want to get a surround view reconstruction from a single monocular camera. So this is a really very amazing startup, if one would call so. There is also a lot of socially relevant research which are highly impactful. Some of them we would try to play videos as we go down. Project Lip to Speech is headed by Professor C.V. Jawahar and team, which learns individual speaking style for accurate lip-to-speech synthesis. Project Angel is about filtering out objectionable social media contents to alert users and redirecting towards positive contents using a cross-platform analysis, focused mostly on young women and teenagers. Project Brain Atlas by Professor Jayanti and team demonstrated for the first time the India's first brain mapping technology to understand differential brain dynamics as per different geographies. And a reconfigurable drone is a prototype for a drone which can reconfigure itself or adapt itself to carry payloads of various sizes and shapes. So I'll get into lip to GAN. I hope we'll be able to see the video, and I hope I did share the audio, or maybe or I think I forgot to do that. Should I go out and? Are you able to hear the audio of the?
No.
Should I log out and log in with the?
Stop sharing and start again.
Reshare.
Stop.
Yeah. I stopped it, sir. You can start again.
Yeah.
Welcome to this demonstration video for face-to-face translation. In this work, we translate the video of a person speaking in a source language to the same person speaking in a desired target language with.
So you are able to hear, right?
Yes.
Yeah.
Lip synchronization. But first, let us see how well we can generate lip movements from human speech. The inputs are used by the face decoder to generate a lip-synced face image in the target pose. We also employ a lip-sync discriminator that checks if the generated face and the given audio input are in sync or out of sync. Since our model is trained on large video datasets, it works for any identity, for any voice, and for any language. Here are some examples of people singing English, German, and Hindi songs.
Twinkle, little star, how I wonder what you are. Up above the world so high.
Und rot und schmecke gut.
सी डोरियों 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 से मैनू तू बांध।
Yeah, so finally, we come to the Technology Innovation Hub at IIIT Hyderabad. Innovation Hub is one of the 25 TIHs established by the DST under the National Mission on Cyber Physical System. Its mandate is to develop technologies at scale in the areas of mobility, healthcare, buildings, systems, and India-specific data. INAI is an initiative to apply AI to population scale problems in the Indian context, combining research and translation, and leverage the strengths of IIITH at large, AI at the KCIS, activities of iHub in data, strengths of Intel, and the public health expertise of PHFI. Smart mobility and healthcare would be the main focus domain for INAI and would align itself closely with TIH activities in these areas. We have also started the Kohli Research Fellowship to attract, very competitive PhD candidates, and the fellowship is very attractive to the tune of 55,000 rupees per month. And we have had 3 fellows so far. Sachin Raja with a Master of Science in Computer Science and 8 years of experience and prior experience. Akash Keti is very unique. He was doing his undergrad here and decided to join the PhD, making use of this Kohli Research Fellowship. Whereas Vishak Duggal had done his master's by research here and then moved over to ABB for 5 years and then decided to come back once he heard about this fellowship. So moving forward, we expect this Kohli Research Fellowship to attract the much needed talent for PhD, because I think eventually the PhDs form the backbone of research in any thriving ecosystem. I will stop here and I would hand it over to Praveen. And,
Yeah, thank you, Madhav. So the rest of the event, we are going to have four eminent faculty who are going to give a short talk. After the short talks, there will be a panel discussion. So Anup is going to be, Professor Anup Nambudiri is going to be the moderator of this panel discussion. So I'm now going to request Anup to take over from here. So Anup, please go ahead.
Good evening to everyone. A warm welcome to the last but the major event of today. We have a wonderful set of panelists who are going to enlighten us, discuss, debate on one of the most important issues that are coming up related to AI, and that is how to navigate this exploding landscape of AI. We have four eminent panelists. I'm very happy to welcome all of you to the event. We have Professor Belaraman Ravindran, we have Professor Mohan Sridharan, we have Professor R. Venkatesh Babu, and Professor Milind Tambe. I would first request each one of you to present your ideas first, talk about the subject for roughly 10 minutes, and then we will get into the discussion. So I'll introduce one by one as the panelists are about to talk. First, we have Professor Balaraman Ravindran. He is a professor of computer science at IIT Madras. He is also a Mindtree faculty fellow there. He heads the Robert Bosch Center for Data Science and AI there. His primary research interests include machine learning, reinforcement learning, text and data mining, and applications to social network analysis. He is one of the most eminent researchers in India today. He has published extensively in these areas at top level conferences and journals. And he also is a thinker, and we would all benefit very much from you in this discussion. Over to you, Professor Ravindran.
I just need to share my screen.
Yeah, please.
So does that look right? Great.
Yes.
Perfect. So thank you everyone for inviting me. I mean, I'm like this visiting faculty at Reply to Hyderabad. I just keep coming so often to your events, and I collaborate extensively with faculty there. So I feel at some point you should give me an affiliate faculty position or something. I'm really happy to be joining you in celebrating the anniversary of the Kohli Research Block, and also in remembering Chef C. Kohli. So I'm going to talk about navigating the exploding AI landscape, right? And so I was given this twin mandate. So the first thing was to pick up a crystal ball, right, and then tell you how AI would unfold in the next 5 years. So let me see how I can do that. So the first thing that's going to happen, right? So whether we like it or not, which frankly I don't like it because it kind of excludes most of academia from doing research, that we are going to see larger and larger and larger models, right? So I don't know how many of you saw this recent model put out by OpenAI called DALL-E, right? And that's that image which was generated in response to the text, a daikon radish in a tutu walking a dog, right? So I mean, things are getting really insane, and then you have this series of alpha 0, view 0, that kind of models being generated by DeepMind, which they blithely will say, oh, it just required like 64 TPUs to train over 2 weeks or something. I mean, it's just unimaginable to me. And then of course we have this 175 billion pound gorilla, which is GPT-3. So things are just going bigger and bigger and bigger, and we're going to see more and more of this as we go along. At least in the next 5 years, right? At some point, this is going to break, and we'll figure out what's going to happen then. Of course, the second direction that we're going to see a lot more attention being paid on is in serious ethical questions that AI is beginning to engender. So all of these are news stories from recent times. Of course, that the image mislabeling there is much older. But then, despite the impressive performance of GPT-3, right, you still see that the significant biases in the language it generates, and facial recognition has been getting things so wrong that many companies are now suspending, research or at least suspending releasing product and supporting products in facial recognition, right? And there are a variety of different scenarios in which AI is running afoul of both ethical issues and legal issues, right? And so we're going to see more and more research in that, right? That's another direction that I'm seeing more. And then, of course, there is this whole federated learning piece where partly due to computational constraints and bandwidth restrictions, partly due to privacy reasons, right? So in the future, it's going to be increasingly difficult to get data to come to a central cloud location where you can do learning, right? So we are going to have to necessarily work with data that is distributed. In fact, we might have to even work in many cases where we don't even have a clear idea. I mean, each node does not even have a clear idea of what is the overall data that is available to it, right? And so that's the direction we're going to go. Increasingly, federated learning is not going to become a fad, but reality of how we have to do large-scale learning, because that's how the data is going to be available to us at all, right? And so all of these, lead us to this question. This is something which I've been trying to push at our center. I have a last slide. I'll talk about that. The Center for Data Science and AI at IIT Madras. So the next couple of years, we are going to focus on what we call deployable AI, right? So there are many challenges. There are, of course, still algorithmic advances that need to be looked at, right? So we need to build better architectures, better training algorithms, all of that, yes. But there is also a significant challenge when I want to look at, hey, how am I going to use these, say, in an Indian context, right? There's a lot of questions that come up in terms of how you do the deployment. So there are things like societal challenges, including things like ensuring fairness, right? Fairness in terms of not only fairness as in that slide that we saw about sending black people to jail, but also fairness in terms of not widening the digital divide in India, and so on and so forth, and looking at how it's going to affect future of work, the societal perception of AI. So in fact we work extensively with our humanities and social sciences people on issues here, right? And then a lot of trust and privacy challenges, right? Robustness, explainability, all of this which we know, but can AI advance to the point where we understand and can give guarantees on the kind of results that the algorithms are producing, right? And then there are issues like liability. If something goes wrong, who is liable, right? I mean, these are things, it looks like, why should computer scientists bother about it? But these are questions that you really have to answer in order to, get into building deployable AI systems, right? And then there are other classes of challenges, which I call data-centric challenges, where you have to worry about the quality of data, the availability of data. In this case, it would be good, clean, labeled data, and so on and so forth. And also, of course, how do we handle drifting data distributions? That leads into another one of these organizational challenges, which is like maintenance. We normally have software maintenance challenges, but with the AI, you also have this model maintenance challenge, and questions about integrating with existing workflow. But there are so many interesting questions that we have to address when we actually start thinking about, not just targeting the next nearest paper, which is great, which all of you should do, but also building solutions that really impact people in real life, right? So these are issues that we want to look at. And lastly, we have system level challenges, looking at computational resources, accessibility, user experience, so on, right? And the second mandate I was given was talk very briefly about how to navigate the AI landscape, because we're going to talk more about it during the discussions. So it's really confusing, right? So, but I actually serendipitously came across this piece of this graphic when I was browsing today. It's from the Trustworthy ML Initiative. So there are a lot of resources for beginners out there, right? There are like seminars, open access seminars, and up to date. If you're on Twitter, there's a lot of information for you to point to. But here are, here is one particular blog that I was pointed to very recently, and I think there's a lot of very useful information in places like that, right? So there are many accessible blogs like this, like Jay's blog, and there are a lot of online courses, lectures, and short seminars, and there are a lot of people tweeting about the latest research work, right? And just reading is not enough. You should play. There are enough open source libraries out there for people to download and start working on it. And talking to fellow researchers and students is a great way. And in fact, whenever somebody joins my group, I say the first thing they have to do is talk to everybody in the group, figure out what they are working on before they, start thinking of what directions they want to move in. And so here is a recommendation: don't compete with big tech, right? So even the whole Kohli research block doesn't have enough compute to fight with DeepMind. But there are many fundamental questions in AI to be answered, right? You really don't have to run after the next large model, right? So you can think about looking at classical AI and see how you can integrate that, right? And explore real world applications, right? So whenever you're looking at solving problems for India, right, which again, Triple Hyderabad has been doing an amazing job in terms of the various socially relevant projects they've taken up. But the thing is, you have to solve it locally, right? So that is another direction where you can find rich sets of problems. You start off by talking about the problem, but then you find that there are so many advances that you have to do to actually tackle it more effectively, right? And this is always my favorite thing: interdisciplinary research, right? And so you have to look at talking to people from other disciplines. In fact, we have found very interesting synergies across disciplines, which I personally did not envisage initially. So we are now working with the same set of techniques on trying to build gene behavior correlate models on white mice behavior on one end, and on the other end, how people interact with intelligent devices in a smartphone. Right? I mean, it's the same kind of underlying statistical model, but it's actually very interesting when you start talking to people from different disciplines. You can see this kind of connections, and so it gives you a greater chance of creating impact. And for me, certainly, it's one of the way forwards for data science and AI, and that's the reason we have a very strong interdisciplinary center at IITA. So I don't want to say more about that at this forum, but if you're interested, you can look up our webpage. Thank you.
Thank you. Thank you, Professor Ravindran, for your nice thoughts. We will definitely would like to ask a few questions, but we will postpone it to after the talks from the panelists. Before we start with the next panelist, I want to remind the attendees that if you have any questions, please feel free to ask them. The way you have to ask is to type into the QA section of your chat, not the chat button, but there's a QA section. You can ask questions there if you are in the Zoom webinar. If you are watching it as a YouTube live stream, you can ask it the questions also there as comments, and we will get it over here. So now we will move on to the second panelist. We have Professor Mohan Sridharan. He is a senior lecturer in intelligent systems at the School of Computer Science in University of Birmingham, and he was previously at University of Auckland and Texas Tech University, and he does a lot of research in a variety of areas related to AI and ML, knowledge representation, machine learning, computer vision, and also in cognitive robots, adaptive robots, collaboration of robots and humans, which is another interesting topic. And he also has a lot of interest in working with the hard and big problems like agriculture, intelligent transportation, climate informatics, and so on. So over to you, Professor Sridharan.
First, a voice check. Can you hear me?
Yeah, good.
Okay, cool. I'll try sharing now. Okay, do you see anything?
Not yet. Let's give it a minute.
Right, did I do something wrong?
It'll be nice if you can.
Yeah, I'll try again. 1 minute.
Yeah.
Now?
Yeah, so the screen is visible. If you could also switch on your camera, that would be great.
Sorry. What did I do? Just a minute, sorry.
It's okay.
Let me do it the other way around. Okay, if I switch on the camera, you're going to see my daughter's toys, but I can't help that.
That's okay. No problem. It's nice to have at least a face top. So
you'll see that's not a problem. Okay, cool. Can you hear me now? Okay.
Yes. Good.
So cool. Thank you for the opportunity to speak today. And as I said, it's nice to meet lots of people now, especially in the UK. We are all stuck inside with our so-called tiers of lockdown changing on a daily basis. Okay, so let's talk something positive. Okay, so today my brief was, I think I got the email from you. saying let's talk about these kind of questions about how to navigate the AI landscape. So before I do that, I'll take a couple of minutes to talk about where I'm coming from, and then maybe I'll try a few slides of talking about what sort of lessons I have learned on the way, so to speak. Okay, so briefly about me, my research primarily sits, if it appears yellow to you, that's correct, the sort of intersection of these areas between robotics, AI, machine learning, with all these sort of terms strewn around, like, in this Venn diagram of things that I work on. But my key interest, of course, is to work at this point of intersection. And also briefly to just tell you again as where I'm coming from, questions that have motivated me. And then this will help understand when in a few minutes I tell you about questions that I think are interesting and would be interesting for more people to look at. My interest has always been on these basic science questions about robots, which are interpreted very loosely in the sense that they don't have to be physical entities. They can also be these software agents, but also in turn about humans themselves, right? So when I ask, for instance, how best to enable robots to represent and reason with different descriptions of knowledge and uncertainty, I also, through this, want to, through these computational models, I also would like to understand how humans do this, right? And the same is true for the second one, how to enable robots to learn interactively and cumulatively, right? These days, there's a large amount of data floating around for different applications. So what humans do really nicely is we learn cumulatively, we learn new concepts. We don't just take all this data and crunch it. Somehow we are able to internalize this and put these in ways and abstractions that they are easy to manipulate and understand. How do we get machines to do this, right? And the third and often what I find more difficult problem is how do you then establish that these robot or sort of computational system that you have built, that it satisfies certain desirable properties. And this can be anything from formal correctness to things like explainability, or sort of being able to trust that these sort of concepts that are by themselves difficult to define. And with these kind of questions, I'm also want to share a bit about the inspiration that that led me to do this kind of research. So this is primarily motivated by research in integrated cognitive systems. So a lot of what I do and what I think are interesting problems lie at the intersection of knowledge representation, reasoning and learning, and potentially control. And these are, I'm not, what I'm saying here will motivate the next slide. So I'm not new at doing this. A lot of people have done this before me. And in fact, we need more people to do this. Is that, like, say the idea that appeared in Alan Turing's 1950s paper on morphogenesis is that probably the best way to design a computational system is to have one that reasons at different abstractions with different reasoning schemes, and somehow have this sort of seamless coupling. Like, so in my case, I look at this as any agent or robot having internally sort of a logician, a sort of armchair reasoner, a statistician who learns from experience, and an explorer who sort of goes out and sort of figures out what's going on in the world, and somehow putting all this together. And if you notice, one of the names I put there is a sort of a 16th century, 17th century philosopher, right? So these ideas are old, but these sort of motivate a lot of research, and there's still a lot of interesting questions to be asked there, right? And a key point I would like to make, which I learned over time, is with all this focus on learning, cognition is central to learning. Learning, why do we learn? We learn to improve performance, right? There is something we want to improve. And so this notion of cognition, of being able to think deeply about multiple steps ahead in time, or sort of to do plans and sort of revise these, to reason deeply about concepts, these are central to doing any kind of learning. Okay, so I, of course, work on different kinds of robots, but that's not the thing. Let me go to the other part of this brief here, right? So what does AI research mean to me, or what I think is sort of important for, I learned this, thankfully, really early, given the advices I had at doctoral during doctoral studies, is that we are essentially engaged in this relay. This is the way I look at what I do, right? So, and therefore, I would say that what I think is very important is to understand the rich history of fundamental contributions. Right? And this helps develop a sense of intuition, like it was drilled into me when I was in grad school, that you should be able to recognize when something is a previously solved problem. This should sort of come automatically to you. And that you should develop this intuition of saying what are really rich and interesting problems, and what are sort of that should have been solved before. You shouldn't just get sort of taken up by, say, what is the buzzword these days. And in this sense, I believe that classical AI research has much to teach us. And here I quote something I recently, for those of you who do not know, yesterday was January 14th, is declared the World Logic Day, right? It's sort of celebrated by UNESCO says that this is the World Logic Day to understand the impact of logic. But what I find in much of the education these days is very few programs in AI or in machine learning teach any sort of logic, right? Like people are a lot of focus is on on dealing with data, but very little focus on logic. And to sort of motivate this is something that a colleague of mine presented, and he said this, and this sort of struck in my mind. So I thought I should share this. It's like Gottfried Leibniz, 17th century, you could call him philosopher, scientist, whatever, right? Like, he viewed a logician's activity, the idea of sort of trying to put things down in logic and reason with this, as being second in importance only to the activities of prophets and kings, who are at that time, if you can imagine, like, they are probably gods or next to gods. When since we have no prophets and kings, anybody engaged in this logician's activity these days, you are at the top of the architecture, like a hierarchy, right? You're doing something that is second to none, right? And he made this sort of really deep comment there. He said, mankind is still not mature enough to lay claim to the advantages which this method could provide, right? So this is a deep statement. What this basically says is we are developing and doing something that has, that improves deep understanding. And I think this is what scientists should do, right? We should be engaged in sort of improving the deep understanding. And even though progress, oftentimes, when you look at these deep questions, can be slow, the impact might seem like, I'm not seeing the kind of impact. It's not generating money, or it's not sort of like, having the sort of practical impact right now. Of course, that is important, and a lot of that is happening. But a scientific question, I believe, should sort of promote this deep understanding. And if you do that, there are many practical advantages, right? Even in current times, when you process data, as I think Ravi was saying a few minutes ago, like, if you combine these kind of logical structures with this data-driven programs or data-driven approaches, we find that there are very significant advantages purely from a computational perspective, but also at a much deeper level in terms of promoting, say, explainability, trust, and all these other things that we care about. Okay, then maybe one more. I'm careful these days. I sometimes write a slide like this and put it in front of students. And I say, with great power comes, and I leave it open. And the kind of answers I get are everything from world destruction to corruption. Yes, all that can happen, especially given the current political climate in many countries. But in the context of AI or scientific research, what I think this does, at least to me, is sort of a deep sense of responsibility and humility, right? In the sense that what we do can have immediate impact, yes, but while doing so, we should understand that other people are going to build on what we say and do. So there is a significant long-term impact, and we have to be careful. And the second point is, again, something that was something I learned really early, and that sort of influences the application domains I pick, is while there are opportunities for applications, all these and the impact we have has to be tempered, has to be guided by a strong sense of social and ethical consciousness. In the sense that what we have, the benefits of AI are immense. As I say in this slide, I have personally an optimistic view that instead of world destruction, what we will have is like, immense, there is immense potential, and we are already seeing applications. But if we are careful about this, and if we sort of like, take care in how we develop this and how we distribute the so-called benefits, then we can have a lot of applications and a lot of impact in different domains. I work in things like healthcare, agriculture, climate informatics, but there can be many others as well. And the key thing, of course, is the third bullet, scientific rigor in what we do and how we report it. And the last slide then is to say, because we said we should talk about a few problems of interest. Personally, I think that to go from bottom up, right? So each person, and this is what I was taught, you should identify and pursue a fundamental research problem that excites you. I mean, you have to find out what that is for you. But of course, this has to be guided by a strong sense of having a knowledge of what's gone on before us, because we continue this long path. And because a lot of what I do has a knowledge representation focus, the logician's dream, this is something that I personally think is really interesting, to have some sense of a universal notation, right, to encode any form of knowledge in a natural and systematic way, and a means to computationally manipulate this knowledge to draw interesting conclusions. And this can, of course, be have a lot of different applications. But what I think also we need a lot more people to look at these fundamental principles, this notion of refinement, how one thing is a refinement of the other, like, in terms of knowledge or in terms of actions, a lot of different things. But also this notion of compositionality, saying that parts together do things better than they do individually, and how to put those things together. Right. And as applications, I would say, please, it would be nice to see more people look at jointly at knowledge representation, reasoning, learning, and control, whether in machines or humans. And definitely do look at principles of classical AI, because they have significant lessons to teach us and have significant impact in how we can develop better data-driven methods. And with that, I'll say thank you.
Thank you, Professor Sridharan. We will now move on to the third panelist. Next, we have Professor R. Venkatesh Babu. He is a professor in the Department of Computational and Data Sciences in Indian Institute of Science, Bangalore. He is again a very eminent researcher, has published at the top places in the world. He has his research interest in a lot of areas related to AI, including from the classical signal processing techniques, multimedia, computer vision, visual tracking, and he has worked a lot on cutting edge research problems, and he's also a very good friend of CVIT and IIIT. I welcome you, Venkatesh. Next.
Thanks, Anand, for the nice introduction. Shall I share my slides?
Yes.
Can you see the slides?
Yep.
Okay, yeah. So navigating the exploding AI landscape is the title given here. Yeah, this landscape is as difficult as neural network landscape, very non-linear. We don't know what is there in future. Yeah, many of the points that I noted down were covered by Ravi. This is the problem when we talked after Ravi. Ravi covered almost half of what I was about to talk also. So this is the popular slide that we keep seeing when AI is being presented, the effect of AI on computer vision. So imagine a challenge. Every year we keep reducing the error rate, and now we are getting, after 2015, we reached better than human accuracy. And yeah, so yeah, Karpati can even memorize and tell 95% correct answers, whereas we can't even do about 50% of them. Again, this slide shows the evolution of ImageNet, how we increase the ImageNet top one accuracy over years. From 2016 onwards, we almost reached more than 90% top one accuracy now, and there is hardly anything to do now. So does it mean that we have crossed the human limit and deep can do better than human? Yes, we have done in some ways, but there are some more glitches pending. So far these models, all the high-performing, better than human models, they use huge net and the huge amount of data. Data was the fuel for all these models. And yeah, data creation itself is a huge cumbersome task. And somebody has to annotate. There is so much of bias that can come in on those things. And the next level of approach is how to get rid of the data. Can we do something without the annotation? So that's where the self-supervised representation learning picked up in the last few years. And now it is one of the hot topics, and hope it is going to be a hot topic in the next few years also. So here you can look at this popular SimCLR approach is showing almost on par or slightly better performance than supervised approaches. Though you are having huge amount of parameters, maybe 4 times more parameter. Without annotation, we can do even better than or almost similar to the supervised approaches. The same thing is shown here in another plot. So where you can see the recent approach, SWAV, it's very, very close to the supervised approaches. Even without annotation, we can go this far. And probably in the next couple of years, probably we can overtake. So this actually reduces our dataset bias as well as make things more generic. It's generalizability is a major thing in machine learning. So also, if you look at what is there for the next 5 years to look forward, so these are some of the points that picked up. How can we overcome the bias which already raised by Ravi? From the data sets, there are many types of bias, background, texture, region, race bias, all those things. So these are the major problems because the data set is created from a particular group and they definitely have the bias. And when you try to adapt the model trained on these data sets, it's not going to perform well in the other data set. And generalizing to in the wild setting is another important scenario in computer vision, where most of the data sets are kind of curated in the labs or kind of with a limited setting. So in the wild setting is a very, very challenging scenario, and hope the next few years we will get more and more algorithms that do well in the wild setting, which is a very challenging setting. And also we should teach the AI models how to give the intelligence of whether this image it is capable of classifying or doing any task on top of this. So whatever it has seen, it should be able to distinguish whether it comes from the training distribution or not, which is very, very crucial because nowadays all the models, they have no such idea. Given any image, it takes and then process and gives some garbage output, which is a major, major problem in AI. So we should infuse some kind of intelligence how out of distribution samples can be detected and eliminated without doing further processing. Also, how we can provide privacy to the data. So that is another major thing which already Ravi spoke about in detail. So that is another major challenge that is facing us. And learning with minimal supervision is going to be there in the next few years because of all the problems with the data set, as well as annotation costs and bias. So can we do the same with the minimal amount of data supervision? So there are many subtopics coming under this: few shot learning, weakly supervised, semi-supervised, as well as self-supervised learning. And the last point is also a very important part: robustness to adversarial attacks. And nowadays, people started coming up with algorithms that can give you guarantee for a particular epsilon ball. Within this particular epsilon ball, we can get you this much accuracy if you put up within this limit. But yeah, robustness actually shows how really the gap between the human brain and the machine. So yeah, simple noise which is added to the image, which can easily derail your huge net, which is trained on millions of images, which shows there is this semantic gap is very, very huge still, even after so much of training with the deep models. And challenges faced by researchers is also an important thing that we should consider, because in our last decade, we were not like this. The number of papers and submissions, they were always under control, and you leisurely write your paper and then submit, wait for the result. Now it is not like that. So number of researchers working in AI increased dramatically, and submission to the conferences are exploding. So if you look at this particular plot, it shows left-hand side, you can see NeurIP submissions. It's almost showing an exponential trajectory. Whereas 3 years back, it was 3,000. Now it is almost 10,000 submissions. The number of papers, again, huge, 700 papers 3 years back and almost 2,000 papers this year. The same trend you can see even for CVPR, where again, you can see the number of submissions increased dramatically from 2000 in 2015 to more than 5,000 papers in last year. This year, we have about 10,000 submissions. So this puts a lot of pressure on vision research, AI researchers. And you have continuously, there is one or the other conference submission coming up. And number of researchers working in this area multiplied dramatically, and you are not the only one working in that particular area. There are almost 10 to 20 people exactly looking at what they are looking at now in the research. Also, we have another major issue because of the industry giants like Google, Facebook, Amazon, all those people. They have huge amount of computational resources, which goes against our academic guys. So what we can do in over a couple of weeks training, they can do over a few hours or maybe in minutes. Okay, and because of the computational, that puts us in a very difficult situation. It's very, very difficult to compete with this kind of a huge difference in computational power. So this is another major challenge faced by researchers. Yeah, it's better to sometimes go and work as an intern, but that's not the solution that we are looking at. Also, there are too many papers to review. Yeah, all of us are doing, we are having every month, we have some kind of a deadline to submit our reviews, and the number of reviewers are actually not going at the pace of the number of papers that we are facing now. And that gives us bad reviews, and the quality of reviews are degrading with every year and the increasing amount of papers. So this, what I told, similar ideas are being explored by many at the same time. So we should be very, very careful and really fast. And that puts us under pressure. And that the negative part of this is, shorter lifespan of research problem. Yeah, you keep waiting for the conference deadlines to publish. So that also brings out some shallow research papers with a little with limited advancements in that. So that is also kind of not good for good research. So how can we cope up in such a fast-paced world? Yeah, so some points already covered by Ravi. So choose the research problem that ideas very wisely. Yeah, maybe you should choose a problem that is going to be very futuristic, and definitely people will come there. So if you should be a Nostradamus, at least to find your problem. So pick up a broad area, right? So don't go into very narrow down your area. Okay, I want to work only in this particular semantic segmentation area, something like that. You should look very broadly in the as a research area before entering into it. At the same time, it should be kind of exciting to you. And yeah, review the current progress in the field and write down the challenges and bottlenecks. So attending talks helps a lot, either through conferences, webinars, and yeah, you sketch out a rough plan and how to solve the problem. Okay, and brainstorm with peers, mentors. That is the main thing that I would like to see, because with the growing amount of literature, a single person cannot look at the entire landscape and then give you the. So it's better to collaborate with your peers, mentors, especially in the lab. So each one working in a different area, right? And it's like you just by socializing with them, you get to know what is happening in this area. Don't be a loner now, especially because things are changing very rapidly. Also, I would suggest to start with the simple proof of concept experiments. Don't get into your bigger data sets, huge models, then you get lost in this huge network and it's very difficult to come out. So use as very simple models and data set to validate your hypothesis. Collaborate with your peers. That keeps you updated all the time, and you know what is happening now, even in this fast pace of research. Yeah, keep discussing. That is the gist behind the slide. And if you look at this particular slide, yeah, adversarial attack, just when we started working in this in 2016 or so, there were hardly 50 papers were there in the entire year. And now, even after 2 years, you can look at it has crossed 2,000 submissions. And this area is also kind of exponentially grew within a very short span of time. So with this, I'll stop, and maybe we can discuss further in the later question and answer session. Thank you.
Thank you, Venkatesh. It was a very nice talk. We will move on to our fourth panelist, last but definitely not the least. We have Professor Milind Tambe. He, unlike others, play a dual role, and he would be a very appropriate person to answer many of the questions that some of you are also posting. He is the Gordon Mackay Professor of Computer Science and also the Director of Center for Research in Computation and Society at Harvard University. And he also serves as the Director for AI for Social Good at Google Research India. So he has this dual role of both being an academic and almost industrial person, and that would be a very nice asset to our discussions today. He's definitely interested in problems that are important to socially relevant problems that where AI could be applied. Over to you, Professor Tambi.
Thank you. Thank you for inviting me. I hope you can hear me.
Yeah.
Okay, wonderful, wonderful. So thank you. The question I ask is, how should a young researcher navigate this AI landscape without feeling overwhelmed? And my perspective is one of AI for social good. So clearly there is an explosion of AI research, but AI is not benefiting everyone equally. And so I advocate to young researchers who may be on the line to adopt a social impact driven approach to AI research. In our view, AI research innovation and social impact go hand in hand. So on the one hand, we want to achieve social impact to benefit, advance the benefits of AI to those who have not benefited from them in areas of public health, conservation, public safety. There are many other areas. But simultaneously, my area of work is multi-agent systems, advancing game theory, social network bandits, and other approaches to multi-agent systems. I wanted to give examples from our own research, which has focused for the past 15 years on using AI and multi-agent systems for social impact, whether it's for public health or conservation or public safety, basically asking the question of how to optimize our limited intervention resources. And I'm going to give you examples from public health and conservation and public safety, just to illustrate my point of how social impact and AI research go hand in hand and allow you to discover problems that may be hidden from other people. And so I'll start with this example of HIV prevention amongst homeless youth. I lived in Los Angeles for many years. Right outside our university, there's a camp of homeless people. And essentially, we would just drive by, don't look at the homeless population, move on. But it's important to see what AI can do for this population. And one big problem is HIV prevention among youth experiencing homelessness. There's 6,000 youth who sleep on the streets of Los Angeles. And the rates of HIV are 10 times the rates of the normal housed population. And so shelters try to spread information about HIV because you can't talk to all 6,000. So they bring in key peer leaders, educate them about HIV, and expect these youth to talk to their friends and their friends to talk to their friends, and information to spread in a social network. This is face-to-face interaction. This is not happening over Facebook, etc. So this seems like the problem of influence maximization in social networks, where you're given a social network graph, you're given edge probabilities of how information will propagate over edges, and you have to choose some peer leaders. So given a network of 100 homeless youth, pick 10 peer leaders to spread information, to maximize information spread about HIV. But this is not standard influence maximization. This is where new challenges come up that others have not addressed. The problem is that in this context, with the youth experiencing homelessness, the social network itself is not known. The propagation probabilities themselves are not known. And now you get to ask the question, how do you spread information in a social network when the social network is not known? So this is social impact driven AI research. On the one hand, this leads to nice AI innovations, but of course, on the other hand, it also leads to impactful work in the sense of this turned out to be the first large-scale application of influence maximization for public health. We just published results of our study at AAAI 2021 on 750 youth experiencing homelessness in Los Angeles in collaboration with homeless shelters, My Friend's Place, Los Angeles LGBT Center, and Safe Place for Youth, where we compared the performance of our algorithm against a baseline. So we recruited 1/3 youth of the 750 in our algorithm, 1/3 for the baseline, and 1/3 for a control group. So we educated the peer leaders using the choices made by our algorithm as to who should be the peer leader, then waited 1 month to see what was the change in behavior. And what we find is that our algorithm, if you look at something like reduction in condomless anal sex, led to more than 30% reduction in this HIV risk behavior compared to the baseline and the control group, which did not achieve anything in 1 month. At the end of 3 months, things started to change, but it's important to have these advantages, have HIV risk behaviors reduce faster. And because it's a dynamic community, having these advantages come to this community faster are important. We also looked at other behaviors and again showed the importance of our behavior. I wanted to sort of give you one other example. As a Mumbaikar, the fact that there were terrorist attacks early in the 2000s was very distressing in these attacks in Mumbai. And so and this is from some years ago, Errol Southers, who was chief of airport police at the Los Angeles airport, approached us to say, can we improve security at LAX? There's 18 bound roads, not enough police officers to be on all roads at all times. There's 8 terminals. We can't have canine patrols at all airports at all times. I picked this example also because I know Professor Paruchuri is on the line, and this is something that came out of one of his papers and was part of his PhD thesis. So I wanted to mention this example. And so the concern for Errol was somebody driving a suicide truck into one of the terminals, as had happened in Glasgow. And so the question is, can we use game theory for direct security resource optimization? Could we convince different scientific advisory committees that game theory was the right approach? Could we convince our AI reviewers? Could we convince the sergeants on the ground? And that's what we decided to do. But this required a whole new model, Stackelberg security games. It's a Stackelberg model because the police commit first to a randomized strategy. The adversary can conduct surveillance and then respond. It's a security game played on targets. And the innovation then are new algorithms that can solve massive scale games. This turned out to be the first application of computational game theory for operational security, where armor got deployed at Los Angeles airport. There's lots of weapons that were captured, news media coverage. Errol this led to many other applications, air marshals, which flight should carry air marshals, how should the Coast Guard patrol different ports. And Errol went to United States Congress to talk about our work.
LAX is safer today than it was 18 months ago. A team of research led by Dr. Milen Tombe worked with our department to develop armor. This software randomizes our vehicle checkpoints along airport access roads and the deployment of our explosives detection canine teams throughout the airport.
And it went on with other agencies giving testimonies to United States Congress about this work. The point being, AI innovation and AI research and social impact going hand in hand. Quickly, wildlife conservation is another such example. You're trying to find these traps or snares in large, thousands of square kilometers. Again, this led to new innovation in terms of green security games. Numbers of traps or snare captures have jumped 5-fold. And now this work is being adopted worldwide in terms of different parks around the world adopting these techniques to try to help save wildlife. All of this work is only possible because of collaboration with the non-governmental organizations that are operating, whether these are homeless shelters in Los Angeles or ASHA workers in Mumbai, who, I visited this TB control center in Mumbai. And it's so moving. I mean, these people are visiting TB patients. And I asked them, aren't you afraid that you yourself will be infected with TB as you go to these and visit these places? And so we are trying to empower nonprofits so that they can use AI tools and avoid being gatekeepers to AI for social impact technology. So here's my advice to adopt more social impact driven approach to AI research. It's not only impactful, but it gives you access to new problems that others are not addressing. Ultimately, the research has to be for something. It's not just about writing more papers. In fact, as we see these, I'm on the, I'm on sometimes on these committees for hiring and so forth. You see these candidates for faculty positions with very, very large numbers of papers. And the question is, what is this doing? I mean, what is the point of it? And so in our research, we find that AI research and social impact has gone in hand. I would say team up with local area nonprofits. There's so many. Arman is one, for example, that we're working with, which works with new and expecting moms in places like Dharavi in Mumbai, or Pratham Books, which is trying to teach kids, Swasti, which is working for HIV prevention among sex workers, among many other challenges in India and so forth. So that's it. In Google Research India, we are trying to bring AI researchers and NGOs together. We've launched a new set of projects recently. There's a whole lot more to say here, but I'll stop here in the interest of time and open up for questions. Thank you.
Thank you, Professor Tambe. That's a wonderful talk. We will now get into the discussion part. So I would like to ask a couple of questions and then get opinion from each of the panel members. So since we started with the discussion on the difficulty of a researcher who is getting into this area, I would like to ask this question, which is a two-sided coin, that is the signal to noise in research. As you say, the number of papers are exploding, the number of concepts that are coming up are increasing, number of researchers are exploding every day. And this means that it's very difficult for us to, as a researcher, to look at the world and understand what is meaningful and what is not. And now this is also percolating into popular science because of the interest in AI. Everybody is talking about new concepts which is going to revolutionize the world. Every single concept is going to revolutionize the world, but as we know, it doesn't happen. So how do we separate signal from noise as a researcher to understand? And related reverse problem is when we put out signal into the world, it becomes noise usually. So it's important not just to understand what is important going on, to understand from the world, but also when we try to publish, how do we make sure that what we say is first of all relevant, and if so, if it's heard. So if you have some thoughts on that, that would be nice to hear. We will go in the same order that we started. Professor Ravindran first.
Oh man, you should start with Venkatesh. He's the one who had all these graphs. Anyway,
maybe we need another deep learning algorithm to classify that. So there should be a deep model where you give your paper and it will say what is the worth of your paper, right?
It's actually, especially with the explosion of papers being submitted to archive, right? So you don't even have your fig leaf of peer review anymore, right? So it's becoming incredibly hard to say, okay, what is relevant, what is not, and what should be cited. In fact, it became an epidemic levels that program chats had to tell reviewers and conferences, please don't expect the authors to compare to papers that are only on archive. Right. So I mean, you're talking about individuals who, I mean, like young researchers who can't make out whether it is valid or not. I think this is pervades the entire ecosystem now. So I think we really, I mean, like Venkatesh said, you need a deep neural network model. This deep neural network is not enough now. So you need to look at something else, right? So I mean, usually the rule of thumb is you look at the top venues in your area, right? And then look at papers that have been published there, and or look at papers in archive that are being cited, right? Or now the new citation index in academia now is how often are papers being tweeted about. So if you have to start looking at those to figure out what is signal and what is noise, and it's incredibly hard. It's incredibly hard. I don't have a ready-made answer for that.
Since you were quoted, Professor Venkatesh, you work on compressed domain signals. Now it is noise level signals that we need to work with.
Yeah, this signal to noise, it's really there very much. Yeah. So the researcher is a matured researcher once he find out what is signal and what is noise, basically. Yeah. So because the number of submissions are enormously growing, right? And every student started reviewing, even, I don't know, first year students, second year students started reviewing. So you can't expect the same quality of review for all the papers, and with a limited set of people. Also, this became a huge business in many of these countries. This metric, once the Google Scholar came in, it became an optimization problem there. How many I will get, how many papers in these places. And people are trying to prevent all these malpractices that happens and then try to reduce these junk items from the conference, but it is really, really not possible to scale up to that huge numbers. And there are random ways. ICHKA is one conference, they did some drastic things last year. They told, okay, 40% of paper we want to do disk reject. They collected some 15 experts, yes or no. Just see the paper for 5 minutes and then say yes or no. So this is the, so we are supposed to do as a senior program committee members, and then 40% they rejected based on that. This is not a nice way of doing. Yeah, we got a lot of criticism from the community, and even my students, they don't want to submit there because they are looking at 10% acceptance rate or something there. No one wants to submit, okay. And this is a illogical way of rejecting things also. So we should find some kind of a middle ground where the good papers are not penalized at the same time, whereas some bad papers can come in. So we need some kind of optimization in this line so that really good students or researchers, they are not penalized because of this overcrowding. So that's what I would say now. We really don't have a solution for this kind of exploding number of papers. Somehow AI should come in and then do the first. Instead of experts doing this 15 yes or no, I think AI can do better job than that. Simply they run over 1 hour. Yeah, you can remove 40% of the paper. Yeah, we can do that. Yeah,
so based on the numbers, we have large number of positive and negative examples also to train our models on, I guess.
Exactly. Yeah, that.
Yeah. That will work for one cycle. Next cycle, somebody will have an adversarial attack on that model.
Adversaries will keep coming in, so we have to be careful. Yes.
So that's closely related to the next question I wanted to ask, but I'll come back to it in a minute. Now, before that, Professor Sridharan, you have something to add?
Probably. Okay. So it's fun to just see them talk about this. Okay. So some things that we have seen here, like I don't know if it will work for paper reviewing and other things. Like for instance, in the UK, if you write too many proposals or papers and it goes through a review here for local venues or local funding agencies, and if it is not reviewed well, if you do this a couple of times, then you're barred from publishing or submitting something for the next period, whatever months or year or whatever, right? So that sort of puts a certain amount of scare in people for publishing sort of garbage and sort of trying to submit some things without being careful about it. And also at the same time, that is matched up with sort of a slightly more open reviewing mechanism, which means that you cannot write garbage if you don't write a properly written review. It's not taken seriously. They're able to improve the quality that way a bit. I'm not saying this will necessarily work on the scale of all large conferences, but I just realized that someone was telling me that he got a email this recently. He tried submitting. I mean, each guy deadline is coming up right now. So he got an email saying you cannot have more than 7 papers. And he was telling me, I cannot imagine submitting 7 papers at the same time to the same conference, but these things are happening. Anyway, so to come to the other point, like I think maybe, I don't know, this seems to work for me, is to not view research as a performance task, but to look at papers or otherwise, not purely in terms of their performance claims, but in terms of their scientific claims. That sometimes helps me. I'm not saying it will again work in all cases, but to say that when I look at a paper and I say, what are your scientific contributions? You did whatever, 2% better than the other person. Yes, that might be important. But more important than that to me is what are the scientific claims or contributions you're claiming to make and whether you can justify them. That sometimes helps me when I read a paper to quickly figure out whether I should bother with sort of taking this seriously or this is just one more claim which cannot really be quantified or compared as in independently. And second thing is some of these venues are making it important, and we try to do this in our research, is to make things open to available to other people to examine. Like, when you force people to make their data and results and other things, programs available, that sort of puts in a certain amount of check as well. Because one hopes, hopes is the correct word, that people are a bit scared to put, generate some random results and also make that publicly available along with their code and data and say, okay, you try it, knowing fully well that they're not going to get the results. But I think the only strategy I sort of advise to students is train yourself to think carefully, right? And train your students to think carefully and critically about papers. And this was something that was passed on, which is why I think research is an tradition, right? It goes on from one advisor to student, so to speak, right? And so to me, what was passed on was when you look at a paper, you're not comparing performance. That's important, but research is not a performance task. Research is about carefully evaluating the scientific contributions. And I think if we do that, it might help. I'll stop there. Thank you.
Yeah. So I guess from So
Mr. Tambe,
yeah, so I guess to add to, I mean, all wonderful points. From my perspective, I mean, clearly, there's an explosion of research and so forth. I guess personally, I've adopted this strategy where we're really trying to work on these socially impactful problems. And generally speaking, that isolates the kind of problems that we are looking at as being quite different from what the general community is looking at. I mean, I gave examples of social networks, of game theory, and so forth, where you're protected because nobody else is worrying about these kinds of problems. And so that gives you a nice area to be working in for long periods of time before other people get interested and start working on them. So that's at least my strategy, and this has worked for us. And there are lots of these kinds of problems for low resource communities where there are open problems and nobody will bother you. I can guarantee you that.
thank you. So that's a very interesting thought. So I would lead that into the next topic, where we say, let's assume that our goal is not just publishing the paper and graduating. We have gone beyond the fray and looking at larger problems. So one of the key issues that I would like the panelists to address is that of the impact of what we do in real world solutions. So there are a couple of points that came out related to it, and specifically the ideas of mismatch of model and the world. So since we are actually trying to create solutions which actually impact the world, we have to be very careful whether those impacts are positive or negative. And there is one more problem that I see in that is, if we are actually creating impactful solutions, then those are going to change the world, and that would change the distribution. So we really need to worry about our solutions that would change the world, the human beings adapting to these AI solutions, and how would the solutions work at that point. So there is always this question of continuously trying to understand the distribution of whatever data that you're working on and being able to adapt to that. There are of course solutions like continual learning that are being proposed, but I would like to hear your thoughts on both these aspects, where would the model that we create, is it an appropriate fit for the data, and if so, even if it is so right now, how would it affect as we move forward? And this can have significant impact on practical deployment of problems. So whoever would like to pick up first, that I don't want to enforce the same order that one person always gets to talk the last time, so that either you would want to
Go in
talk
reverse order.
of your go in
I
reverse order
propose
is
go in
also
reverse
fine.
order, yeah.
Yeah, so Professor Tambe, you can start with, and then maybe.
So I guess this is one of my pet concerns here about really encouraging socially impactful or otherwise impactful research. And this goes to our AI conferences valuing algorithmic innovations as the sole metric for choosing papers. And if we want to really see real world impact, then we need to have evaluation criteria that are different from simply algorithmic innovation. At AAAI, for the past 3 years, we've been pushing this AI for social impact track, which has different evaluation criteria. It asks the question of whether there was real world impact. It asks the question of whether there were difficulties in getting data. So it has a set of different criteria, and the kinds of papers that come out are slightly different, or maybe quite different. In fact, so if we have to engage in large scale experimental work in the field in order to show the benefits of an AI approach versus something else, a traditional reviewer will mainly just say, well, there is no contribution to AI because you didn't innovate in terms of new AI algorithm. But it is science being done. You are scientifically checking, you're doing experimental work. And so it is important for us, if we really want to see this kind of impactful work, to push for new tracks to have different kind of evaluation criteria. We've pushed for AAAI to adopt this special track with special evaluation criteria, and I hope that we can persuade other conferences. Perhaps Cards COMAD could be another such conference that will have a special track.
We're already doing it next year. Wait for the.
Awesome, that's fantastic, and I hope we can persuade NeurIPS. I hope we can persuade ICHKAI also to adopt these kinds of criteria for a special track where they value impact on the real world as an important outcome of the work.
Thank you. Professor Sridharan, you want to give it a shot, or you are muted right now, please? Yeah.
Sorry, I was just saying that according to your original order, I was third, but that's okay. I'll go. Sure.
Oh, I'm sorry. I messed up, but that's okay. You can, now that you are unmuted, you can start.
No, it's okay. I mean, I can let Professor Babu speak.
Professor Venkatesh Babu, yeah, please.
Oh, okay. Sorry about that. Yeah, before looking at the impacts, I would say, impacts definitely come from really good papers. And most of the good papers are published in the top venues, especially in conferences now. Okay. And I would rather, since we are sitting in India and looking, all our audience are Indian, I would say how many papers we publish in these forums first to get an impact. When I looked at this NIPS, what happened recently last month, there are about 2,000 papers published, and we have Indian papers. If you look at, there are about 15, not even 20. That is the number that we have. It's hardly a 1% of the papers coming from India in these top venues. CVPR, again, the similar statistics. And with this 1% of contribution, I don't expect that we are going to do some great impact in this thing. I would look at other way. How will you maximize the submissions? Even you write some garbage, okay, it's okay. You submit something to these conferences and get some feedback. That habit should come actually. Then only we can. Somebody was from TCS, he commented our publication record is so bad compared to China. Yeah, it's really, really bad for the country of 1.3 billion people. 1/6 of the population contributing only 1% to the top conferences. If we make it at least 2% in 1 year, that is a major thing. I'm not going to look at the impact as of now because we are still far from that sitting here. So if you increase the number of submissions, automatically when the good papers come out, we are going to have some good impact there. So that is what I feel now at the current state we should do rather than looking at or filtering our submissions here. Yeah, that's about.
Professor Sridharan, next.
Sorry, it sounds very strange. Just say Mohan. Okay. So okay. So especially since Sridharan is my dad's name. Okay. So okay. So okay, good. So I will probably just try and briefly address what you said and just make one other point. So you asked about these changing models, right? This the notion of non-stationarity. I mean, especially with both Ravi and Milind on the call, they understand this really well. So so there are very nice ways of dealing with this. Like scientifically, we know how to deal with changing models and other things like that, right? We have nice ways of saying that if we have built a model and things change. I mean, with more of these data-driven techniques, where there may not be any inherent model. It might be a little difficult to probe and see what it's representing and then see how to change it. But in general, I think the field is pretty mature in terms of saying that if these models change, are there ways to figure it out and are there ways to fix it? In the broader, AI community. Right, but to come back to this other point about I think if I'm correct, Milind, yeah. So you were saying about this having these special tracks and stuff. I feel we should also augment this by training people. Often what happens is when people send this, if there are such a large number of papers and you don't get the right person, you're really literally at the mercy of those 2 to 3 people who read what you say, right? Nobody has the time to go at 6,000 or whatever number of papers you submit to a large conference. Even with these multiple layers, with the senior program committee, area chairs, whatever, in some sort of more smaller scale conferences, in robotics, we have things like this RSS, in certain kinds of AI conferences where the number of papers are less, you might be able to pull this off. But I think part of this also requires, what is this? training of the reviewers. By that I mean, like, the students and other people that we interact with. I think it's important to train them also over time to both recognize and evaluate work by using these broader metrics. Like, it's not just your performance. So for instance, because I do this cognitive systems research, there are instances where we only give use cases, like, look, in this cases it performs, look, it tells us a lot about the inherent behavior of the system. That is valued a lot too, but it will not be valued in a traditional conference. Right there you have to have this 95% better than the 94.7% that some other algorithm had on the same benchmark data set or whatever. So I feel part of this, having encouraging this broader work, is also training people to value it, and to also, like, prepare them to understand that impact can be in different forms. Thank you.
Yeah. Professor Ravindran, you want to?
Yeah. So yeah. So there are like two parts to your question. I guess on the other, the Pran is literally answered the first part, right? About how you're going to talk about the impact, and I agree with, I mean, what Milind said. In fact, I'm completely buying over into what Milind was talking about, right? I mean, I mean, witnessed by the fact that I also started doing a lot of things with the social scientists, talking about applying things in the field. In fact, collaborating quite a bit with Milind now, in looking at AI for social good and so on and so forth. So impact doesn't have to come in terms of the larger academic community. Impact can come from your local ecosystem that you are in, right? And I think at least some parts of AI, right? Things like, linear regression and auto-regressive models and stuff like that, right? Which are now relabeled as AI, right? They are mature enough for you to build products, right? Around them that you can actually start deploying very, very simple things that you can actually talk to people and figure out, how you're going to build solutions around it. In fact, I've been talking to a lot of local engineering colleges where guys have been doing some remarkable stuff, like, building small applications for, they're very, very, very local, farming community that they are part of and things like that. So it's really amazing in what levels you can have impact, right? So impact is one thing, right? So there are many ways in which we should be able to measure impact, right? Not just in terms of citations, publications, and so on and so forth, right? The second thing is, the one other question you asked is, okay, suppose I actually put out these systems and deploy them, right? And that's going to change the behavior of the system, right? How do you account for that? Wasn't that the second part of your question? Since you made me go last, I almost forgot what the question was. Anu?
So, I mean, I was asking that, when you deploy AI solutions, there's also a impact of it in the sense that would change the behavior of people, and hence the model would change.
So that is something which we don't study at all. I mean, we brought this question up, right? I mean, there are a few people, right? A few groups around the world that are actually looking at this human AI interaction bit, right? I mean, there are companies like, Google and Microsoft and Facebook and a few universities where there is a very good collaboration between HCI, right, like human computer interaction people, and AI. I mean, if you come to India and you say HCI, they say computer vision and speech, right? So in India, we really don't have an idea of what HCI really means. But then there's this whole piece out there, and from the AI point of view, we don't even have a good understanding of how IT changes people's behavior yet in India, right? So AI is adding another whole level of complexity on top of it, and there's a lot of work that needs to be done. And I don't think we have good answers for how we are accommodating AI, the effects of impacts of AI into our AI model, right? And this is one of the reasons I was talking about model maintenance. Just like you have software maintenance, we should do model maintenance. In fact, this reminds me of an Asimov short story where a computer that's supposed to solve all the problems of the world finally crashes because it's not able to model its own effect on the world. So we are in early days yet, so we don't know how to answer that question. I don't think so.
Thank you. So I would like to pick up a question that was asked from one of our YouTube viewers. This is from Gayatri Priya, and she's asking, doing research, there are two ways to approach it. Do we do research to generate deeper understanding, or doing research to solve a real life problem? And do these things ever meet? If so, how do we choose such problems where you would do both, doing research to do understanding as well as these are two calls that probably appeal to most researchers. So it's a very nice question in that.
Could I just ask you to clarify that question again, please? Like research as in research to have, what are the two parts again?
So the first part is doing research to generate deeper understanding, and second is doing research to solve a real life problem. So the research for the sake of knowledge gaining, understanding of anything, a topic, or second is to actually practically solve a problem. So
and the question is oh, sorry, go Milind, go.
Yeah, so let me take this question because so there is this wonderful book called Pasteur's Quadrant, pasteurization of milk and all that. So that Pasteur's Quadrant, and so there's a TLDR of that is that there's a 2x2 matrix where on the one side is whether it's research is useful or not, and whether research is basic or not. And so you get four areas basically. So somebody like Niels Bohr, they're doing fundamental work to understand things for the sake of understanding without necessarily trying to do something useful. And then someone like Edison is trying to do something very useful, but not necessarily to gain a fundamental understanding. So the one area is pasteurization, Louis Pasteur. So the basic idea there is that you're trying to do user-inspired research. You take a problem from society, but then you develop something like a germ theory of disease, which is a fundamental understanding of the world. And so the two, in Pasteur's case, met. Now, this is not necessarily the scientific style for every scientist. Clearly, for Bohr and others, that was not the scientific style. And so it depends on what kind of a scientific style you want to adopt. And it's to everybody's taste as to which one you want to follow. So I guess I sort of look at Pasteur as the person that I would want to follow, in terms of the kind of impact he had in in society, while simultaneously trying to improve our fundamental understanding of biological systems. So, of course, and then there's the fourth quadrant, which is neither useful nor fundamental, and nobody should be doing that.
Okay. Thank you. Any other, it's not necessarily that everybody has to answer, but if you have any points to add to that, that'll be great.
Could I say something?
Yeah, please.
Could I say something? So I feel part of this is also incorrect specification. What I'm trying to say is adding knowledge by definition is useful. It's not this or that, right? Like, so if you add to fundamental knowledge, you are by definition doing something useful. It's like impact, right? If we start redefining this word to mean different things, then of course one will not allow for the other in some sense. I think the person's question of saying that should I do A or B, they should do what motivates them, right? I would strongly say that anything that fundamentally adds to knowledge by definition is useful, because that's what research is all about. You're adding to the body of knowledge, and somebody else sometime can do it. It's not, but at the same time, I wouldn't advocate that just do that. Right? If sort of some practical problem motivates you, like Milind was saying, if you can find something that is at the intersection where you're doing something that is a practical problem, but also you end up solving a fundamental problem as a result of that fundamental science question, that would be nice. But it doesn't have to be a choice. Both are useful.
Thank you. There's another
very
question.
Quickly, just one line to add to that. So Gayatri, Priya, if you really want examples of it, go look at Professor Millen's research, where the two meet. Yeah.
Thank you. That was a good.
That's a very, very kind comment, and same to you, Ravi.
Good. So there is another a question from Dallas Miranda. Question is it's addressed specifically to Professor Mohan, but you could, I guess, anybody could answer that. Maybe I'll read it out, or even though you could see this. So the question is, in pursuing research to get closer to simulate human level intelligence, a scientifically sensitive attitude might be to look at cognitive neuroscience research, and the two fields could influence each other. So how good are the current conversations between the two, and do you think there's a need to have people who sort of look at both sides and in a general way so as to understand intelligence in all its pluralistic dimensions. It's a
Okay, so
long
if I
question.
understand this question correctly, it's a I think the question is like, it would help to have cross pollination of ideas with fields like neuroscience, right? And to what extent is this happening? I would say yes. I mean, I like to think yes, it would really help if we can have people talking to each other. And I would also say that there is evidence of this happening, and even at the local scale, right? Like if I were to not go further at all, I'm in Birmingham in the UK. If I just look here, we have a program that looks at computational neuroscience and cognitive robotics together, right? So there are definitely benefits of putting these ideas together, and I would say it is a good thing to happen. And I would also point out that it's not like, we are not unique here in the sense that there are other instances of these things happening in other parts of the world as well. And yes, when this happens, you bring in people who bring in different perspectives, and that's always a good thing when you're trying to I don't necessarily think simulate human level intelligence, but whatever, like, to try and understand, improve understanding of both how humans do a lot of these fundamental tasks, like, represent reason, and try to sort of build computational models that can then help artificial systems. I'll stop there.
Thank you. Yeah.
You should promote Bapi to a panelist and get him to answer that.
So yeah, so that's maybe a plug-in from IIIT. Yes, we do have a very strong cognitive science research group, and which is part of the KCIS, and we do try to bring in that perspective into the research. Yes.
If I can just say one more thing, like anytime you do cognitive systems, you are looking at integrated systems. That's always a good thing. I'll stop there.
So any other comments if you have? Otherwise we can move on to this one more question that is specifically well, it could be to anyone the way it is written here, but so can you elaborate on what are the scientific contributions that are not improvements in metrics / performance? That is the within quotes scientific contributions that are not in improvements in performance or metrics. I ask this because the time I started reading research in AI, it has always been improving metrics in some form or the other. And if a problem that you're solving is known to the community, and if it is known to the community, if you try to solve a new problem, then this text is a little jumbled here, but if you try to solve a new problem, then it's like you start the cycle for the future, where probably metrics would now be established, and then people try to beat the metrics. How do you convey this scientific contribution to a reviewer when most look at the metrics and evaluate the quality of the work? So if you are trying to chart a new path, then where metrics don't exist, then how do we go about this?
If I think this is directed to me somewhat, it feels like it. Is this to me? Because I did say something about this before. Yeah, okay. So I did not say that, like, I said let's not focus at research as purely a performance task. I did not say there should not be metrics. All I was trying to say, I think, is that this can be, you can look at different metrics. Like, instead of saying I have this large data set and I want to look at how accurate I am in comparison to, say, this other algorithm, I could look at in terms of performance artifacts. And again, I look at this example, I say, in cognitive systems. When you have these large, what we call architectures with different components, right? There is something that learns, something that reasons. Now you can't throw sort of 100 samples at it and say how accurately you do. It does not demonstrate the capability of such a complex system. So then what you do is you create some use cases and you say, under these cases, can I get it to provide a performance? Like, for instance, let us say I have a system that reasons with some incomplete knowledge and is able to provide some partial descriptions or explanations, as they are sometimes called, of what's going on internally. If I can give it some really sort of like, and this is some fundamental work in AI, like, this is not me. This is people like, Herb Simon, Alan Newell, and more, even Patrick Winston, who passed away recently. Like, these are people who have looked at these problems. I'm just a small guy who came on later, right? So like, in that case, what you do is you bring in sort of these use cases and you demonstrate the capabilities on those use cases. And then you say, okay, how has this improved our understanding of the internal reasoning of the system? And thereby, hopefully, of how humans go about doing it. I mean, that's the sort of fundamental question that has motivated a lot of these really sort of like, initial, like, these pioneering AI researchers, right? And that's what I was referring to. Like, if you purely look at this as saying, will I get this next paper in a conference? Hey, that depends a lot on chance. It depends on what reviewers you get, what track you publish, what the metrics are, and so on. But in terms of a scientific contribution itself, I'm saying that it does not just have to be an improvement in accuracy. You could have, even though your system does not do on average better than the other one, you could have brought about some fundamental addition to knowledge or understanding in that area. And that is and should be valued, was the point I was trying to make. And this can be used often to select a sort of good paper on something that you should read and understand more carefully among, say, some 200 odd papers on the same topic. That's the point I was trying to make.
I wanted to add maybe a related point, which is that in some cases, establishing metrics is indeed very difficult. And I'll give two quick examples. One very, somewhat older one, which is in distributed constraint optimization and so forth. It was very difficult for people to understand how to measure performance of these systems. And so the papers ultimately started becoming what is the right metric to measure the performance. So since there was, some disagreement on what is the right metric, papers are essentially just about what is the right metric. And that's one direction to think about. In other cases, like the work where systems were deployed, like we have done for something like counterterrorism or something like that, it's a deterrent measure. You don't really know what it has prevented. And these kinds of things then become massive challenges. And then that it's very reasonable to write. I mean, you then start seeing papers on how to measure impact of these actual systems that are deployed in the real world. And the evaluation itself requires that we engage in research, write papers about what is the right kind of evaluation and so on. So I'm essentially saying that this metrics and evaluation itself is an important topic of research, and it is important that we treat it that way and accept papers that debate the right kinds of metrics and so forth.
Thank you, Professor Malin. So that's important because in practice, like we have one of the largest AI systems in biometrics in the world, the Aadhaar system in India, and there also you have similar issues where you are trying to push away fraud and people not getting second dual identities and so on, but there's no consistent way to measure this thing because you never know what you missed. So the ways of addressing those kind of questions becomes very relevant when it gets put into practical situations like that, I believe. Okay, so a related question was addressed at Professor Venkatesh. Should we always be focusing on SOTA, always the accuracy, or should other metrics like efficiency and of the running algorithm and ability to run on edge devices? So, I mean, essentially the question is again about metrics, but it is, since it was addressed to you, I would like to.
Yeah, thanks. Yeah, metrics is actually another major issue in artificial intelligence. Yeah. And for some time in olden days, they started with some metric and we keep on doing that metric. For example, PSNR was a not so good metric for image quality assessment. And it took a lot of time to change that metric itself. And yeah, so these things keep happening. This is also a kind of evolution. The metrics, getting the correct metric, it never happens at the first stroke. It keeps on changing. For example, even in the recent scenario, if you look at the major challenge that we saw is when you say you are fooling the model, right? Switching the label, basically. For example, I'm saying this model is, I made the model to fool this particular class. So instead of saying it as one dog, it says some other breed, some other dog actually. But this kind of fooling is not actually fooling because at a metric level, you don't get to see whether it's a really you're fooling the model or not. Okay. For example, a one dog to another dog switching is metric is taking this as you fool the model. Whereas saying dog as something very, very different as a bus or a vehicle or something, that is real fooling actually, semantically, right? So we also try to push some kind of algorithms to change this metric, but things won't change immediately because it's a kind of a competition that goes on increasing your fooling rate all the time. doing this. But in the just 1 layer below, we see all these models are kind of very fragile models. You can, it's not even attacking the model properly and changing one dog to the other dog. Even that mistake we do often. It's not a semantic mistake. It's a simply syntactic mistake. So whenever the model makes a semantic mistake, that's when you should say this is a real fooling. But there is still no metric available. We are trying to push some metrics, but it takes time to get into the correct metric. So always you fight for the right metric all the time. Sometime at least some reviewers will listen to you, and yeah, definitely. It happened over across various modalities in text community, VQA community. It happened often because the old metrics are not the correct metric. But that will bound to happen, but you need to be patient to push those metrics. That is my point.
Yeah. So,
Thank you.
Anup, can I add to that?
Yeah, please.
So at least in the NLP community, I think they're a little bit more receptive now, figuring out that many of the metrics that they have really don't measure, coherence, semantic, any kind of meaning in the text and so on and so forth. There are a lot of different kinds of measures and metrics that people are proposing. Now it has become like a cottage industry, right? So you propose new metrics in that community. So I think the larger question was, should I be, looking at the SOTA, right, and then try to beat it, or should I change the narrative and say, hey, okay, I'm not trying to beat the performance, I'm going to do something else, right? Look at it. But again, you're running after another metric, right? So you're talking about, the question talked about, should I talk about implementation efficiency as opposed to, pushing the accuracy with whatever metrics you have by another 0.03% or whatever, right? So, sure. I mean, so all kinds of advancements are needed, and yeah, as long as we are talking about a poorly informed peer review system, you can't get away from this metrics, right? So that, I mean, all in a larger whole, everything that we have been talking about keeps coming back to that, right? So, and yeah, so metrics, yeah, it's an evil but we have to live with it for a while.
So there is a related question to that. I would like to pose it to both Professor Ravindran and Professor Tambe. Asking, can we actually define metrics for improving social good? Rather than, saying something like, how would you define such a metric, and specifically focused on more like the fairness, transparency, or privacy kind of aspects of it? Not, I mean, there are already metrics on bias or harm and stuff like that, but more of how do we, are there any metrics that exist which are measuring things like fairness or transparency or privacy? And if not, how do we go about looking at such things?
So certainly
Tambe,
certainly for fairness, there is now work on fair influence maximization, for example, and the metric there is to check whether the benefits of influence maximization have reached different groups of interest. Here, it's men versus women, LGBTQ versus others, different racial groups, and so you can actually measure the impact of whatever public health benefit you're trying to achieve by spreading information about this public health within a social network across all of these different groups. So that's one of the metrics that can be used to measure fairness. And one of the there's obviously a trade-off then between performance and something like fairness. And at least on our side, the conclusion that we've reached is that a AI system by itself cannot make these determinations as to what is the right trade-off, and to offer a parameter, I mean, basically some sort of a lever for a human being to change this, so they can trade off fairness to performance based on the right kind of whatever they know about the system, so that the AI system cannot make these trade-offs. I mean, in general, it is very, very important for us to accurately measure what is the actual impact of the benefits we are proposing. It's not enough to say we are motivated by HIV prevention, then do some work in simulation, then we write a paper and say now we achieved HIV prevention, if you're really trying to achieve social impact. it is important then to follow up, actually show that this works in the field at the very least by working with the community and showing that it really improved them. Otherwise, the NGO might have spent a lot of time with you, trying to discuss everything with you, and then you took their data, you published a paper, and then, I'm done with this work. This leaves a very bad impression on the NGO, and for the next researcher, the NGO will not collaborate with them because they feel like they've been exploited, and basically their work, all of their time was wasted. So it is important to test things out in the field, and until that is done, I would not call it AI for social impact. I would call it AI for writing a paper, but not AI for social impact.
Thank you.
I completely agree with everything Milind said, right? So in fact, if you're talking about measuring the effectiveness of AI in social impact, right? So we really don't look at the measures that the AI community talks about. You talk about the measures that the social science people talk about. The people who are working in the field, right? They have their own measures of impact, and you have to make a change with respect to that measure. It doesn't matter if your classifier has become 3% more accurate or not, right? So we don't have to worry about metrics. The metrics are already there. It's just that you don't know how to optimize for it. So you tend to, wink at it, right? Oh yeah, that's what they do. But we have solved this more well-defined, clean problem, right? And so that's not the way to go, right? In fact, I'd actually take issue with Milind. We don't have a good measure of fairness. Okay, so let me give you an example. I don't know how much time we have. My clock says 8. How loquacious can I be
So
in
we
the
are,
answer?
we are close to, we can, since we started about 10 minutes late, I am taking the liberty to push it for another 10 minutes. So
Okay, fine. So let me give you a slightly long-winded answer to that.
So I must apologize. I have to leave at 9:30. I have another meeting to go to. So I'll stay to listen to Ravi's answer, but then I unfortunately will have to leave.
Sure. So
thank you.
here is a definition of fairness, right? So I am a higher education institution. I'm going to admit people only on the basis of their performance in the entrance exam. I'm not going to look at anything else because that is the most fair way to get people into higher education. People agree with me as a good measure of fairness? It's not, right? I mean, that flies in the face of all the social justice things that we are trying to do in India. Right? You talk about, hey, where did they start from? And we have to give them some kind of a handicap. Right. So I mean, so fairness itself, it ties in a lot with what is a social, what's a social ecosystem under which you are operating, right? So you have to talk about a whole bunch of history before you define what is fair, and we don't have a clue as to how to do that. So there must be a knob that defines what fairness is, not just a trade-off between fairness and accuracy. Yeah.
So I wholeheartedly agree that the AI system has, can provide like a Pareto frontier of all of the different possible trade-offs and let a human being finally judge. And so the AI system should be designed to have this kind of ability, not to present a point solution saying, I know best for you what is fair, but give you that kind of Pareto frontier. I really just want to thank you all. Excellent discussion. I really enjoyed this very much. Thank you for inviting me, but I have to leave. I'm sorry. I made another commitment for 9:30. Thank you. Thank you.
Thank you, Professor Tambe. We'll look forward to talking to you later.
Thank you.
Okay. So I would, there are a couple very simple practical questions from a couple of students who has come up. So I'll summarize those two and then ask you that question together.
Before you go further, may I just make one point?
Yes, please.
Yeah, so I was just looking at the chat since you told me there are questions and other things. I think PJN made this point of saying that if you sort of try defining a metric, we'll have another metric race for defining a metric for social good as well. And I think like with other things, like, I think you've asked a couple of questions about transparency, about metrics and so on, for which, depending on the application, if we listen seriously, there may be ways to define it, but we often struggle to come up with good common computational, whatever, metrics or models that will apply. And this also applies to your question some time ago about this sort of, how do I deal with models changing when there are humans involved and other things when you apply it and stuff. I still strongly believe the answers are there in sort of like, the social sciences and other places. We just don't take them. We just don't, probably because people don't have enough time or whatever, we don't take them seriously enough until we start applying things in that particular application. So I'll stop there. Go on with your other questions.
Yeah, so since there are many students attending, they had some very practical kind of questions. They say, getting admission to a top level university PhD program seems to be extremely competitive these days. So there are two directions. Can you? Is it better to directly go, or should I work in a industry which is investing in AI so that I can work in that kind of area, or should I do a residency program in some university where we can get some experience and then apply? So it's, if you have any practical advices, quick ones would be nice.
Since this was addressed to Ravi, he should answer it.
It was addressed to both you and Ravi. That's fine. I combined those two questions. Yeah, please.
Yeah, sure. And we talk about setting up great PhD programs and research and improving research quality in India. And these guys are asking us questions about how we can go abroad. I don't want to answer the question.
Okay.
Hey, who did it? They should be allowed to do so too.
No, you should. IIT Madras and IIIT Hyderabad
Times have
also
changed, Mohan. Times have changed.
Okay.
Okay, so since I was asked this question, I'll just give a sort of blanket answer. There is no probably a clear path I can suggest for anyone. I don't think any of us can. It's basically they have to decide what works best for them. If they had a good problem to solve, I think any good university, whether it is IIT Madras or IIIT Hyderabad or some other university in some other country, would be happy to talk to them and take them on to pursue their problem. The key thing is, can they spend the time and the effort necessary to carefully look at things and try to come up with an interesting problem, or choose to pursue an interesting problem. If they do, the path, there are many paths.
Okay. So I think it's time to wrap up. So I would like to ask one generic question to three of you now about what do you see, the future of AI kind of direction from a layman's perspective. Do you have, people generally put this paint two pictures, one of the doomsday perspective, the other is, the glory is coming, everything is going to be wonderful once AI is here to take away our bad problems. So if you have any take on either way, and from a layman's perspective, if you could say something so that people who are listening on YouTube, if they are not necessarily researchers in this AI area but would be interested in what experts would think about this. So Professor Ravindran, you can start from there. And
yeah, so for me the most likely outcome, right, most wonderful outcome is we stop talking about AI in this dichotomy, right? So AI is not anything different from it's a transformative technology, right? I mean, so was the steam engine, right? So I mean, the human civilization has gone through many transformative technologies. At some point of time, it becomes commonplace that we don't start talking about it. I mean, humans understand it, right? I mean, so everybody, even common people, will start understanding it, and so we don't really have to worry about whether it's going to be the panacea or it's going to kill all the human beings on earth. It's not going to go there, right? It's another transformative technology. It's like any other tool in humans' hands, and eventually what you're going to see is a lot of beneficial applications come out of AI. There will be a few people who would be using AI for wrong things, right? And right, so that's how it's going to be, right? Eventually it's going to get absorbed into the society. It's not going to be, already it is happening, right? I mean, you pick up your phone, right, your smartphone, you're using so much AI in it already, it doesn't matter, right? I mean, you don't even think about it. You're not thinking about, okay, this particular thing that recommendation that Facebook gave me, was it evil? Is it going to consume me? Which it probably will, but you don't think about it anymore. So I think the future of AI is that it's no longer a glorified technology.
yeah, Professor Venkatesh Babu, since Professor Sridharan talked just now.
Yeah, future of AI is I don't know, because there are many of my colleagues who actually don't like deep learning, especially. There are many guys like that. Okay, they say, okay, it's the second wave of the AI. Okay, it came and went in 70s, and now it is. We are waiting for the balloon to burst. I'm waiting for maybe another 5 years. It's gone. Now we'll be back to track. So that is what they expect. Actually, they say it's not going to have any impact. But I seriously believe whether it is impacting or not, at least from Indian context, the internet, all this intelligence provider, they kind of have made the platform uniform, whether you're in a city or in a village. Now you can educate anyone online this pandemic has taught us a major lesson. Okay, so you need not reside in a city to work. You can be at your home and then do the same work. You can be at your home and learn things, and you can be at home and get medical advice. Yeah, this is very, very crucial where you don't have huge hospitals, all those things, where all the social, so what is it, AA for good people are also looking at. So definitely these positive avenues are happening, and it will definitely improve our, it will make kind of a level field. You need not go abroad to learn all those things. In olden days, yeah, it was not there. You had to go sit in the class and then learn. It is no more. It's not like that. All the professors, top guys come to you in your hand, and then you can listen. You can switch off him. You can switch on, do everything. Okay, so everything is at your fingertip, and it will make things actually level. It's a kind of a leveler. So wherever you live, yeah. So if you wish, you can get whatever you want, and you can. So that is a major thing that will help us to improve our society as well as the kind of make everybody look at the same level. That's what I would say.
Yeah, you can listen to the top professors at 1.5x, 2x speed also.
Yes.
That's nice.
When
Mohan, you
it
want
is
to add
Indian-
something about it?
Yeah, yes. When it is Indian professors, it's probably 0.5 speed is what students need. I'm told I speak very fast. Okay. Okay. So I will probably add maybe to this. Like I would strongly say that it's not to say, for instance, that I think to what the like was said just now, like to sort of claim that somehow this is whatever number of wave and therefore it will sort of burst. Is now I don't think it's a fair point, because like it has produced several practical benefits and it will continue to do that. Probably I would just add and say that that to see, I mean, I would personally feel it's not the Terminator scenario. It's more of a like positive outcomes can come from it. That's my take on this. But I would say that part of this also depends on how we go about training people to deal with this. Like for instance, the example that's often given is, look, like the people were like pre-industrial age, an industrial revolution happened, and then there were I mean, I'm not even talking about technology, I'm going even further back. But the key thing that was required there was to train people to deal with this and to sort of have a nice form so that people can, format in place such that people could benefit from these developments as they were happening, right? And to a significant extent, history shows us that there was success. So in order for AI to progress and produce positive benefits and somehow make sure that it's shared somewhat between among say different people, like, and it's not just benefiting few, I think what also matters is both from the sort of formal education level to educate people to understand what the historical precedent, not just go with what is currently in vogue, but also to sort of train people to so that they are sort of have this broad outlook and they understand what can and cannot be done, how things can be used, would actually maximize the benefits, right? These days it's easy to sort of for anyone to pick up some data sets, apply some algorithms, implementations that are running around. But the key skill that they then need is to say, if I give you a new problem where you don't have ready-made data and the problem definition given to you, okay, do we have people trained enough so they can sort of do something positive and make something positive come from the sort of tools that are currently available or will be available in the future? That, to me personally, would be really interesting to see. Thank you.
Thank you very much. It was a wonderful discussion. We covered a lot of topics related to the challenges in AI, about the positives, about the potentials of AI, and very interesting aspects about how to look forward to in what is going to come. Thanks a lot to all the panelists, Professor Tambe, who is not here yet, Professor Ravindran, Venkatesh, Mohan, all of you. Thank you very much. And this is concludes our session for today's anniversary session on Kohli Research Center that has been set up to look into this area and trying to develop collaborations also. And that's one of our key objectives, to develop connections with other researchers, other students, and try to develop and create an ecosystem where practical solutions can be done. And that is also one of the motives of IIIT to do societally relevant research. Thank you all for joining us. If Professor P. Jain, if you have any more words to add.
Oh,
Could I just interrupt before PJ goes? Could I just say one thing? I want to echo what Madhav said in his chat. Wonderful moderation, nice organization, Anup. Like you did a very good job. Thank you.
Yes, wonderful to thanks to the panelists also, Mohan, Ravi, Venkatesh, and Milind for making it so lively and interesting. And thanks to Madhav, Praveen, and others, Anup, everybody to pull this off. And it was nice. Ravi has offered himself to be an adjunct faculty at IIIT. That offer is open to others also. So thank you very much. Thanks everyone for making this such a good event. And let's do more.
I think Mohan is also an adjunct faculty, if I'm not wrong.
Okay. Thank you.
Thank you all. Good day.
Thank you.
Bye.